Transformations of functions. The graph of a function can be transformed by either shifting, stretching, shrinking, or reflection. The elementary transformations of a function f are captured in function notation as follows. Translation. Shifting up or down is given by f of x plus k. Shifting left or right is given by f of x minus h. Stretching or shrinking vertically is given by a times f of x. Stretching or shrinking horizontally is given by f of bx. Reflection over the x-axis is given by negative f of x, and reflection over the y-axis is given by f of negative x. Use the function g of x equals the absolute value of x for each problem below. Write a rule or formula for the new function after the given translation. We want to shift the graph up 7 units. So that would be the absolute value of x plus 7. To shift the graph down 5 units, that would be absolute value of x minus 5. Shifts the graph down 8 units, that is the absolute value of x minus 8. And shifts the graph up 10 units, the absolute value of x plus 10. And there are all of the answers. Use the function f of x equals 1 over x plus 3 for each problem below. Write the rule or formula for the new function after the given translation. Shift to the left 2 units. So this is going to be f of x plus 2. Because if we go to the left, we're going to have a plus sign here. So that would be, plugging in x plus 2 here, 1 over x plus 2 plus 3. So all I've done is replaced this x with x plus 2. If we want to shift to the right 4 units, that's f of x minus 4. The reason why this is a plus sign is that this is actually 2 negative signs, x minus negative 2. Because the format is x minus h, and in this case, h is negative 2, which is why we're moving to the left 2 units. Therefore, if we're moving to the right 4 units, our h value is positive 4. So that x minus h becomes x minus 4. All right, so that becomes 1 over x minus 4 plus 3. If we want to shift to the left 7 units, that is f of x minus negative 7, which is x plus 7. So 1 over x plus 7 plus 3. Shifting to the right 9 units, that's f of x minus 9, which is 1 over x minus 9 plus 3. And there we go. Stretching or shrinking the graph of f of x vertically away from or towards the x-axis is given by a times f of x. If a is greater than 1, then f of x stretches away from the x-axis by a factor of a. If a is between 0 and 1, f of x shrinks toward the x-axis by a factor of a. Consider f of x equals x squared, here in red, and 2 of its transformations. G of x in blue is 2 times f of x, so here we have a narrower parabola because this point has stretched away from the x-axis. And h of x equals 0.5 f of x, which is the yellow parabola, which is wider. And you can see that same point here has stretched toward the x-axis. Stretching or shrinking the graph of f of x horizontally towards or away from the y-axis is given by f of bx. If b is between 0 and 1, f of x stretches away from the y-axis by the scalar 1 over b. If b is greater than 1, f of x shrinks towards the y-axis by the scalar of 1 over b. Consider here in red, f of x equals the square root of x. 2 of its transformations. In blue, we have g of x equals f of 2x. So you can see here that this point here has shrunk toward the y-axis. And then in yellow, we have h of x equals f of 0.5x. And this point has stretched away from the y-axis. Use the function f of x equals 2x cubed minus 1 for each problem below. Write the rule or formula for the new function after the given transformation. 3 times f of x is going to be 3 times 2x cubed minus 1. So that equals 6x cubed minus 3. Here we have 5 times 2x cubed minus 1. So that is 10x cubed minus 5. And here we have 1/2 times 2x cubed minus 1, which gives us x cubed minus 1/2. And there are our answers. Let f of x equal 5 plus 1 over x. Write the rule or formula for the new function after the given transformation. All right, so we're going to plug in 2x for x here. So that gives us 5 plus 1 over 2x. So instead of x, we plug in 2x. Here, that gives us 5 plus 1 over 6x. And here, that's 5 plus 1 over 1/3 x. But you could also simplify this to 5 plus 3 over x. And there we go. Let f of x equal 6x minus x squared. Describe in words what happens to the graph of f after the given transformation. F of negative x will be a reflection over the y-axis. But let's just plug in negative x here and see what we get. 6 times negative x minus negative x squared gives us negative 6x minus x squared. Here we have a reflection over the x-axis. So that would look like negative 6x minus x squared, which would be negative 6x plus x squared. F of negative x is a reflection over the y-axis, and negative f of x is a reflection over the x-axis. Let f of x equal 2x cubed minus 5x. Write a formula for the new function after the given transformation. Reflect f across the x-axis. So that's going to be negative f of x. In this case, that would be negative 2x cubed minus 5x, which is negative 2x cubed plus 5x. Reflection of f across the y-axis is f of negative x. So that's going to be 2 times negative x cubed minus 5 times negative x. So that is going to be negative 2x cubed plus 5x, which actually is the same answer in both of these cases. And here we see that we get negative 2x cubed plus 5x when we reflect it across the x-axis or the y-axis. The graph of a function can be transformed by shifting, stretching, shrinking, and reflection. The elementary transformations of a function f are captured in function notation as follows. Translation looks like f of x minus h plus k. Distortion will be a times f of bx, where a is greater than 0 and b is greater than 0. Reflection across the x-axis is negative f of x, across the y-axis f of negative x. And altogether it can look like this. Here's an example of multiple transformations. Let f of x equal x squared for x between the values of negative 1 and 2, including those values. Now define a new function g in terms of f where g of x equals 2 times f of x minus 2 plus 3. When working through the transformations, remember that order matters. So we're going to begin with f of x equals x squared on this domain right here. Our first step is going to be putting this negative 2 inside of the parentheses. That gives us x minus 2 squared, so we move to the right 2. So here in red's our original, then we move over and we have a blue graph right here, and that is f of x minus 2. Next, we're going to put this 2 out front, so now we have 2 times x minus 2 squared. So now we've distorted the graph to be a little, the parabola is now thinner. And then finally we have this k value at the end plus 3, so we just shift the whole graph up 3 units.